Yay! Hello, lovely humans. Jen Foxbot here. In this episode of Math Monday's Machine Learning Edition, we are going to look at how we actually minimize the cost function. And remember, this is the equation that measures the difference between our machine learning predictions and the actual data that we train our model on. So, as a reminder, it's a tricky question or tricky equation to remember. So M is the total number of examples in your training set. How much data do we have? And this is basically a squared error function, and it's a slightly fancier average difference. The square helps us to deal with negative signs and that sort of stuff. So we're going to work through minimizing the cost function by hand so that we can better understand what our algorithm will ultimately do for us. And since we're going to do it by hand, we're going to keep it simple. And we are going to use a very basic linear equation of the form y equals mx plus b. But we're going to use our machine learning hypothesis function in for y, since y is already taken up by our data set. So in this case, we have an h theta, which kind of tells us that we're dealing with unknown parameters that we got to figure out. It depends on x, and it's going to be in the form of theta naught plus theta 1 times x, where x is our variable. Whoa, what happened to my x there? Woo, let's do it again. Okay, there we go. Since I want to be even lazier, we are just going to set this to 0 for our data set and work with a nice clean line that passes through the origin. Since we're going to do this by hand, I'm going to write out a table to help us keep track of the different quantities that we're going to be dealing with. So we have y, which is the actual data set. We have x, which is our variable, which is what is the same between our hypothesis function or the machine learning prediction function. And y. Both y and our hypothesis function depend on x, right? Because in both instances, we're putting something into the function box and we're getting something out. Ideally, we get out the same thing so that this goes to 0 and then our cost is 0, aka our model behaves the same as our training set. In reality, it's much more complicated, but that's the goal. We want to get out the same thing that our actual data gives us. And then we also are going to need to figure out what h of theta x is. So what we need to do is to figure out what the right value for theta 1 is given a set of data points. So again, let's start with this nice simple equation where we just have y equals x. And remember, it's simple for us, but it's not simple for a computer. Okay, so in this case, it may also help to draw a graph. So we have y and x, and we have 1, 2, 3, 1, 2, 3, x. Boop. These are our data points. And so let's just make a guess. And let's say we pick theta 1 equals 0.5. Okay, so then we would calculate our hypothesis function. Well, I guess I should back up and say, let's say we make a guess for this. Now, what we need to figure out is what the minimum of this function is. How do we find the minimum? Well, let's start plugging away and see if we can start to notice a trend. And then we'll use that trend and apply it to more complex situations and make our life easier going forward. Yay! Okay, so we plug in theta 1 for our hypothesis function. I'm actually going to make a quick note here to just say that, like, we know that y equals x, but we need to write an algorithm to figure out how to get to this, given that our machine learning program only sees the data, it doesn't see the pattern. Okay, so we plug in theta 1 for h of x, and so in that case, this would equal 0.5. And we calculate the value of h of x for this x value, so we can kind of hide this. And so if x equals 1, then h of x is going to be 0.5. Ooh, this is different. Okay, if x equals 2, this is going to be 1, and if x equals 3, this is going to be 1.5. Okay, cool. We're working with a very small data set, makes our lives easier. In reality, we would have hundreds, thousands, probably hundreds of thousands, if not millions of data points, which is good. Usually more data is helpful. In this case, m equals 3, and we're going to calculate the cost function with just theta 1. So we only have one parameter. Again, makes our lives a little easier. Okay, so j of theta 1 equals 0.5 equals 1 over 2 times 3, because we have 3 data points. And now we do the summation. So I'm going to put brackets. H theta of the first value is 0.5 minus, and the actual y value is 1. So minus 1, and we gotta square it. And then we add the second one, because that's what a summation means. So in this case, we move on to the second value. H theta of x is 1 when x is 2, and y is 2 when x is 1. And finally, we add in our third value, which is 1.5 minus 3. Okay, and we square that, and if you crunch the numbers, you are going to get 3.5 over 6, or something like 0.58. Yeah, okay, cool. 0.58. So j of theta 1 equals 0.5 gives us 0.58. Okay, let's do this for negative 0.05 and see what happens. Okay, I'm gonna switch that around. We're gonna put this here. We'll keep track of. So in this case, we're gonna have the same thing, but these are all gonna be negatives. Okay, so dun 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 dun. Ultimately, since we have the squared error function, our equation is really going to be the same. So we have 2 times 3. Well, actually, that's not necessarily true. Okay, let's just do it and double check. Okay, so we have negative 0.5 minus 1 squared plus negative 1 minus 2, is that right? Yeah. Squared plus negative 1.5 minus 3 squared. Okay, so we're going to get a 1 over 6 times a 1.5 squared. Negative is going to cancel, plus 3 squared, which is going to be 9, plus a 4.5 squared. And here's where I pause the video to actually do the calculation, because I didn't do this one yet. Ha, thank you. Wait 1 second. All right. Okay, so I use a calculator because I don't do arithmetic anymore. I don't need to. Yay for calculators. Use the tools when you got them. Okay, so this equals 31.5 over 6, which is 5.25. Okay, so now we know that this is 5.25. Okay, let's do one more, and then we're going to plot these values. Yay, plots! Okay, so we're going to move this to 1. And you're probably like, whew, finally, we're going to pick the right value. But remember, a computer doesn't know that. Okay, so clear our column. This is how we clear our cookies on the board. Okay, so theta 1 equals 1. And in this case, we're going to have the same values as the actual y values. So 1, 2, and 3. Doesn't equal 0.5 anymore. So we have 1 over 2 times 3. First value of h, 1 minus first value of y, or I should say the value of h when x equals 1 and the value of y when x equals 1 squared, plus 2 minus 2 squared, plus 3 minus 3 squared. Look at that! Hey, these all go to 0. What's up? Okay. So it turns out this equals 0. 0 times whatever is 0. 0 over a fraction is also 0. Fortunately, it's not undefined. So, yay. It is actually 0. And so now, let's plot this and see if we can find a pattern. Because we hit 0 and we're like, huzzah! We have minimized our cost function. Check. Let me eat my cookie, please. No, we didn't clear. Okay, so bringing it back. So if we plot j as a function of theta 1, I should say, because we're ignoring theta 2 or theta naught for simplicity, we get, if I make some text marks, okay. So when theta 1 is 0.5, j is 0.58, so it's right around here. When theta is 1, j is 0, so that's a fairly easy point to make. And when theta 1 is negative 0.5, so right around here, j is 5.25, so 1, 2, 3, 4, 5. It's right up here. Okay, so now if I draw this, I might start to say, huh, that looks interestingly like a parabola. So for funsies, let's do one more. Yeah, okay. Let's say that theta 1 is 2. Okay. And in this case, we would get 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. And j of theta 1 equals 2 equals 1 over 2 times 3 of 2 minus 1 squared plus 4 minus 2 squared. Whoopsies, too many brackets. Plus 6 minus 3 squared. Okay, so 1 over 6 times, this is going to be 1 squared plus 2 squared plus 3 squared. 1 plus 4 plus 9 is going to be 14. Oh, foo, I don't know what that is. Hold on 1 second. I probably could figure it out, but I got a calculator right off the screen, so we'll use that. Haha! Alrighty, ready? I hope that you also use a calculator to figure that out. Or your brain. Your brain is even better. Okay, so when theta 1 is 2, we get the cost function, or j of theta 1, equals 2.33. I was repeating, so I'm going to put a little bar to be like, it goes on forever, but I can't write that many 3's, so we'll do 2 with a bar. So we get theta 1 equals 2 over here. And then we go up to 2 and a little bit higher. Hey, look at that! It is a parabola. So this is handy dandy because we're like, we did actually minimize our cost function. This is the minimum point of our parabola. Unfortunately, parabolas do have a minimum. Unlike straight lines, which are like, what is the minimum? It keeps going in negative infinity. But a parabola does have a minimum. Yay! So this is what we mean when we say minimize the cost function. We are literally looking for the lowest point of the parabola. Well, when we're dealing with 2 dimensions. Okay, so that leads me to what we are going to wrap up with, in that our cost function is really going to have more than 2 parameters. Again, like I said at the beginning, we dealt with the simplest example we could so we could build up a fundamental understanding of what's happening. So in reality, we're going to have multiple dimensions. And so if we have 2 dimensions, we're going to have a cost function that depends on 2 variables. So our vertical axis is going to be j of theta naught, theta 1. We're going to have theta, I don't know, theta naught over here, theta 1 here. And we're going to get something that's like a bowl. Oh my gosh, can I draw a bowl? Yeah, look at that. We're gonna do that so it's like you can't really see through it. Okay, something like that. And so we're gonna look for the point down here. But another way to plot this is to look at contour plots. So just like map makers, cartographers, haha, that's what they're called. Just like how cartographers were like, how do I make a map showing different elevations of the Earth's surface if I only have a piece of paper? Well, they figured out contour maps, which are 2-dimensional representations of 3-dimensional surfaces. And so you have something where, like, you might see something like this. And the closer the lines are, this kind of indicates that, like, this is where your minimum is. So again, this would be theta naught, theta 1. Each curve represents the function where this is the same theta 1 and theta 2 for j. Whoops, theta 0 should keep consistent notation. 1 and theta 1. Okay. So contour plots are going to pop up a lot in machine learning. But again, we really want the minimum of this contour plot. Okay. Oh, sorry, this is my bad. This is not the same. It's the same value for j. As I was writing that, I was like, that doesn't seem right because theta 9 and theta 1 are changing. Yeah. Okay, trust your instincts. Okay, so really what we're doing with machine learning is we are minimizing the cost function and we're using a technique called gradient descent, which is what we'll get into next time. And it is a way for us to write into code how to minimize this cost function. 2 dimensions is more difficult than 1 dimension, and most machine learning algorithms are dealing with very high orders of magnitude. So lots and lots and lots of parameters, maybe like 100 or 1,000, sometimes even more. Like those natural language processing models, those have millions of parameters. We're not doing that by hand. We want to be lazy, so we use code. Yay! Okay, I hope this was helpful. Please let me know if you have any questions about minimizing the cost function, and next time we'll get into gradient descent. Yes! Bonus points if you have an idea of what kind of formula or mathematical technique could help us to minimize this. Hint, it's in calculus. Sneaky, sneaky. Okay, thank you very much for watching. Please like and subscribe if you enjoy this channel. It's always really helpful for folks to spread the word. It helps get my videos out, and then more people watch them and learn, and that makes me really happy. So thank you very much. Okay, I'll see you next time, friends. Yay, bye!